All right, for example 3, again, we want to start by looking at our two denominators and factoring first. Lucky for us on this one, x plus 2 is factored as well as 4x minus 1. So next step is to highlight and find the LCD. So in this case, if I go to highlight, it looks like there's nothing that they have in common. So the LCD is simply going to be x plus 2 times 4x minus 1. And again, I'm going to find those domain restrictions really quickly. If the LCD is as we wrote it, x plus 2 equals 0 when x is negative 2. And 4x minus 1 would equal 0 if I solve that when we are looking at an x value of 1/4. All right, so we found our LCD. So we can build our fraction x plus 2, 4x minus 1 on the denominator. And now we got to go back up to the original fractions and think about what's missing from each of the individual fractions. So x plus 2 is obviously missing the opposite fraction or opposite factor 4x minus 1. So we're going to multiply that for our first one. And for the second one, we'll do the opposite, x plus 2 for this one. Now here again, this is a subtraction, so I'm going to change this to add the opposite and make that 3x negative. So when I distribute it in, I'm going to send in a negative 3x, and then I got to send in the x over here. So when we go to write our new fraction, x times 4x will get me 4x squared. X times negative 1 will get me negative 1x. And then we've got negative 3x times x gives me negative 3x squared. And negative 3x times 2 gets me negative 6x. All right, let's combine like terms here. So we have 4x squared and negative 3x squared. That'll be just x squared. And negative 1x and negative 6x will give me negative 7x, still over that common denominator that we just found. Now, again, our last step is always to simplify if possible. So I do want to try and factor the top because there is a GCF of x here. Unfortunately, though, as I now look at the entire expression, when I put this common denominator back on the bottom here, factoring didn't help us simplify anything because there's no common factors. So this is actually simplified as much as it can be. All right, one more. We've got example 4. This time we have 3 fractions that we're adding together. And note that one of them is a subtraction, so we have to be careful as we approach that one. All right, so again, we're looking at 3 separate fractions. So step 1, no different. We have to factor everything. Good news is 2 of the 3 are already factored. X minus 1 and x minus 3 are done. The third one, however, is a trinomial. So I'm going to start by using the x games and the trinomial technique. So top number would be 3. Bottom number is negative 4. So our two numbers would be negative 3 and negative 1. And then we'll rewrite this so we can group. So x squared minus 3x minus 1x plus 3. And then we'll take out the GCFs of the first 2 terms. That would be an x, left with x minus 3. And then the GCF of the second 2 terms, no number here, so I'm going to put a 1. But looking at the signs, I have a plus right here. I need it to be a minus to match this one. So I'm going to take out a negative 1. So then we get x minus 3, and these two, again, match. So that means this trinomial over here could be written as x minus 3, x minus 1 from the GCFs that we got on each of the 2 terms. Now grab your highlighter, and then something interesting happens here. I see x minus 1 here and here, and I see x minus 3 here and here. So everything ends up being highlighted, but I had to use 2 separate colors. So those 2 different colors are going to create our LCD for us. So the LCD here is going to be x minus 1, x minus 3, which is actually this denominator right here. So that one's already ready to go. Real quick before we forget, reviewing domain restrictions. If x minus 1 and x minus 3 are the denominator of this fraction, then the problem points are going to be at positive 1 and positive 3. All right, so our common denominator is x minus 1, x minus 3. Now we have to go back to each individual fraction and determine what is missing to finish out the LCD. So if I look at the first fraction here, x minus 1, that's half of it, but I need to multiply by x minus 3. Second fraction, x minus 3, I need to multiply by the other one, x minus 1, to complete that denominator. And then the last fraction, like we said, this one already has both parts of the LCD, so I don't have to change anything there. Now here again, they threw a subtraction in here. So what I'm going to end up doing is I'm going to note it. There's a negative here, draw my attention to it. And when I go to write that new numerator, I'm going to keep it in parentheses and distribute the negative later. Because for these problems, since we're multiplying a binomial times a binomial and a binomial times a binomial, I'm actually going to have to FOIL or use the box technique to get my new numerators. So working on that right now. 3x plus 1, we're going to multiply by x minus 3. So 3x times x gets me 3x squared. 3x times negative 3 gets me negative 9x. And then 1 times x gives me just 1x, or x. And then 1 times negative 3, negative 3. So there's our first FOIL. Now, next is that subtraction. So again, I'm going to put a negative sign here and use parentheses to distribute that later. Then we've got x minus 1 times x minus 1. So x times x, x squared. X times negative 1, negative x. Negative 1 times x, negative x. And negative 1 times negative 1 is positive x. And then thankfully the last one, we don't have to multiply anything. We just have to tack on this x plus 1 from our third fraction. So there it is. Now, before I combine like terms, again, I'm going to deal with this negative and add the opposite to everything inside this set of parentheses. So now I can just combine like terms. So looking here, all the x squareds, we got 3x squared and negative x squared. That'd be 2x squared. Adding up all of the x terms, take a peek through there. I see negative 9 and then 4 additional x's, so that'd be negative 5x. And then we've got negative 3 and positive 1. And another negative 1, so that would be negative 3. And still all over x minus 1, x minus 3. Now, again, we've seen this quite a few times now. We have to try to simplify this as much as possible. So I'm going to take a look here at factoring the numerator. And I see it's a trinomial without a GCF, so I'm going to go straight to the x. Top number, be careful, this one has a coefficient of 2 out in front, so we need negative 6 over negative 5. Two numbers that multiply to negative 6, but add to negative 5, we want negative 6 and positive 1. So the numerator was 2x squared. We're going to use these two numbers to fill in the x term, so negative 6x and positive 1x minus 3. And then we group each two. So we can take out a 2x for the first two terms. We're left with x minus 3. And then the second one, we have x minus 3 here, so I'm just going to write plus 1 times x minus 3, because these are now identical. So I can rewrite our fraction as x minus 3 on the top. That sounds good. And then our two GCFs were 2x and positive 1 to complete the trinomial. And then our common denominator, x minus 1, x minus 3. And thankfully, we didn't do that work for nothing this time. X minus 3's will cancel. And my final answer here can just be 2x plus 1 over x minus 1. So a lot easier and less work to look at than that original where there were 3 fractions being added or subtracted together. So at this point, You have 5 practice problems that are going to be split up over the next 2 days. You're more than welcome to work on them all at once, but they are due tomorrow, handed into Google Classroom. Let us know if you have any questions, and good luck.